The first rule of wave energy. Whatever is efficient wave maker, it is very efficient wave energy converter. And here we can see a typical wave tank. The blue things there are really the flaps that make waves, and there in the middle there is wave roller on scale 1 to 22 getting wet. And it is very interesting that this idea to generate electricity out of waves didn't come from university people. It was Mr. Koivusaari, who is a famous Finnish commercial diver. He had his eureka moment in the early 90s when he was diving in a shipwreck and saw a big piece of hull rocking back and forth in the searching wave. And it took him 10 years to really establish the company. And in the beginning of 2000, he established the company. And now we are here. We have secured some 5 million euros of early stage funding, and we have strong local patent coverage for the thing or the concept, because we are really the pioneers on this field. And on 2009, we were the first company that secured 3 million euro grant from European Union under the protocol FP7 call, which was participated by 20 of the leading wave energy companies. Is there a market? Yes, there is. The biggest untapped resource within the renewable sector. Our in-house estimate is that really the feasible market for this type of technology would be plus 100 million, so sky is there. Feed-in tariffs are already in place in Europe, and let's say big countries like Spain and France are following up these, Portugal, Ireland, UK. Advantage, really the story in wave energy, it has been that those concepts have been developed since 70s. And there has been a lot of drawbacks. So if I talk about wave energy, people usually think that, okay, it's something floating, something buoy, something there out there in the offshore. And we are really developing technology on nearshore, and there is significant advantage here. First, the survivability, which has been the biggest thing on offshore. No 100-year freak waves during the storms. Then it's a significant lower design criteria, which is, of course, significantly lower investment cost. Shorter subsea cable lays, on average 10 times less cable than you need for offshore. The industry is already getting consolidated. There's other 2 talented teams developing similar type of flap thing on nearshore, which is a great thing. On offshore, there's a lot of different type of things. Nobody knows which will be the winning technology. And of course, we can see really the values here. We are able to generate profitable projects already on a smaller scale, like it was in wind in early 90s. So a few words about the technology, why we believe that this is really the winning concept. We are dealing with those and keep it simple and robust. It is just a big flap hinge on the sea bottom. And when we deploy multiple flaps in one unit, we get the megawatt scaled unit. And when we deploy megawatt scaled units, we have a wave farm or power plant. We generate the electricity in a very simple way. It's closed loop, hydraulic circuit. The flap is rocking back and forth, pumping the ram back and forth. We have hydraulic pressure driving the hydraulic engine, which is driving the generator. Operation maintenance, it is a submerged system, so one might think, okay, it might be expensive. No, it is not. It's based on very simple thing, ballast system in the platform. We just need low pressure air. Only thing that diver do is go down, attach the hose, and we are able to do everything else on the surface. Do we have evidence? Yes, we do. First of all, it's very important. We have been operating the real environment, real devices. We have been generating electricity out of waves with 10 kilowatt machine. It's our baby here in the middle. Then we have done a lot of background work in CFD simulations, WAMIT simulations, and also most very important, we have been doing tank testing in different universities, in University of Helsinki and University of Porto. We have third-party verified results for our simulations and for tank testing. Stage of development, we are just getting wet in full scale next summer in Portugal with our 300 kilowatt demonstrator. It is our T4 motor. We can build the Mercedes later. We have already secured installation license inside Natura 2000 area, with this big statement that this is really environmentally friendly technology. We have 1 megawatt commercial grid connection license, and really there's only one moving part exposed to the seawater, it's the hinge. Everything else is inside completely sealed system. and it has a very low visual impact because it is submerged device. Okay, one might think, okay, do you have the economics there? I really like to highlight that what was the generation cost on early wind and on pre-commercial wind, and what was it with solar or PV some years ago when those companies were starting up with their technologies. And this is our statement and our target in the demonstration. We are validating the generation cost of 400 euros per generated megawatt hour. On pre-commercial stage, we will go below 200 euros per generated megawatt hour. It is very easy to prove. We just have a bigger nominal capacity device, which means bigger flaps. We are not doing it now because it's a big step from 10 kilowatts to 300 kilowatts already. How to do this? Really, on short term, we will want to establish commercial proof for the technology. And on midterm, not to enter in the valley of death, we are building up a project pipeline. We have already secured one letter of intent for the pre-commercial project. We are looking to secure at least 2 more during the demonstration project. There's interesting discussions going on with the major utilities in Europe. We are very closely looking coast of Ireland, UK, Spain, and also very interesting west coast of US. And our target is really to be the key technology and operation maintenance supplier in the wearable band implementation. So very, very similar to the companies that are manufacturing wind turbines. Here's our hockey stick. We can start arguing about this. It's based on annual new installed capacity. Funding, we are looking to secure 10 million more euros to bring the technology into the commercial stage. And we have secured this 3 million euro grant already, what was mentioned. The team, how can we deliver? Really, we have a core team of 13 persons, network of 40, European specialists, Finland, UK, Portugal, Germany. Our technical officer, Mr. Savolainen, he has a very long background on history in offshore in engineering from North Sea. Mr. Kasanen, he used to be a project manager he was the leading project developer in a Finnish company that was related to water technologies. It was a few years ago sold to Japan. He didn't want to move to Japan, so he joined our team. Mr. Järvinen, he is the former director of Fortum Fluid Dynamics Laboratory. And me, I'm one of the founders of the company, and I've been also doing a lot of things with renewable technologies like wind. Here's the summary. We are short on time, so we can speed up, and you may start asking already the questions. Thank you.
Okay, thank you for this. Thank you for this very concise presentation where you covered everything what an investor wants to know, but I'm sure there are some questions.
Yeah, 2 questions. First is about manufacturing. Are you planning, who will do that? And the second is, do you have any estimates on the cost, capex per megawatt when you come up in say, a series of 5 or 10 machines?
Okay, answer the first question. Now we have been it's outsourced, and we have subcontractors, and basically in the future it's the question of raising capital. You know, it's very capital intensive if you start building your own factories. Answer the second question, that's the important one. Really, the target is to reach the, let's say, investment cost level of 1.5 million euros, around there. That's what I believe that per megawatt. If you compare to the wind energy technologies, really on onshore, now the investment cost level is around 1 million euro, a little bit less. But this is a completely different environment that we are talking about.
Regarding the technology, usually in this kind of hockey stick models, when you have that, okay, we establish this kind of growth, one of the big risks there, or big sort of cornerstones, could be that you cannot find the technology needed, i.e. the submerged generators or this kind of stuff. Is there some risk on the technology that you are using on this sense?
Not really, because we are not building a prototype on top of prototypes. we are using only technology which is already in industrial use. The generators that we are using are normal ABB generators. The phase frequency converters are very, very normal industrial frequency converters. Nothing special on those. The automation system that we are using, it is based on normal process automation. So very, very simple.
Last question.
Regarding to customers, do you think I suppose the customers will be ultimately be power companies, and I suppose they will be very large projects. And do you think these kind of projects are requiring external funding or funding from the suppliers as well, as we have seen in the windmill projects and so on, that it has been quite challenging actually for suppliers to supply without providing, for example, capital for the project?
Yeah, we know that, and that's why in our business plan there is stated that we could be partners in few showcases to really be also a partner in the SPV. But really, it is such a capital-intensive industry, so we, of course, would hope that we don't end up in that game. But we will see. But we know that's the real thing, and that's why we have been heavily concentrating on big utilities that really can make the investment on their own balance sheet at this stage.
Okay, thank you. Thank you very much, and open for the next presentation.